Today we're going to be discussing graphing linear inequalities in two variables. Please make sure you have your 6.7 notes in front of you and you are following along and writing down the following notes. Linear inequalities in two variables is a linear inequality in two variables is the result of replacing the equal sign in a linear equation with less than, greater than, less than or equal to, or greater than or equal to. Now we're actually going to start graphing these inequalities in two variables. So for example, if I have y is less than 3x minus 2, we're going to go ahead and graph this not on a number line, but on the four-quadrant plane. So a graph of inequality in two variables is the set of points that represent all solutions of the inequality. So before we might have said that like x was greater than 6, but now because we have two different variables, we're going to put this on a graph. And when we put this on a graph, it's going to look something like this, where we say all y is greater than that line, and we're going to shade above it because that's where all the y values are bigger than. You also will need to check solutions of linear inequalities. For example, if I give you like 3x minus 4y is greater than 9, and I ask you to test to 0, you would just plug in 2 for x and 0 for y. So that would give you 6 minus 0 is bigger than 9. Well, 6 minus 0 is 6, and 6 is not bigger than 9. So you would say that this is 0 is not a solution. That doesn't make this inequality true. 2, negative 1, you would get 6. Negative 4 times negative 1 is positive 4. So you get 10 is greater than 9. Well, that would make 2, negative 1 a solution. So you would say that is a solution there. When you're going to be graphing these inequalities, you're going to have to look at whether your inequality has the or equal to sign. If it doesn't, then your line is going to be dashed because it does not include those values. And if it does include or equal to, then it's going to be a solid line to represent that it does include those values. So like before we were using open circles and closed circles, now you're using dashed lines and solid lines. You're still going to use the arrows on both sides though. So if you're ever like not sure which way to shade, you can always test a point on the boundary line. To see if it is a solution to the inequality. You're also going to shade the half plane containing the point if the ordered pair is a solution, and shade the other half plane if the ordered pair is not a solution. So here, if you have y is less than negative 1/2 x plus 4, first things first, you see that it's less than, so we're going to have a dashed line. So I'm going to start by going ahead and my y-intercept is 4. I go down 1, right 2, down 1, right 2. Now this is saying that I'm going to not have a solid line. So you want to make sure that I can tell the difference between your dashed line and your solid line. If I have to guess which one it is, it's going to get marked wrong. So I would leave a generous space there to show that that is a dashed line. Now it's saying, well, y is less than. Now, automatically you might know that, well, less than is below that line, but you could test 0, 0 to see if it is a solution, and sometimes I might have you do that. So here, if you put in 0, you have 0 is less than 4. That makes that a solution, and it contains 0, 0, so you can shade down as well that way. Picking a coordinate, and if let's say you wanted to say, well, does 10, 10 work? If I put in 10, 10, let's just make sure it's not a solution. Is 10 less than negative 1/2 times 10 plus 4? Well, that would be 10 is less than negative 5 plus 4. 10 is not less than negative 1. So that's kind of a nice way to see that that will not be a solution here. If I have to graph the inequality x is greater than 4, I could test 0, 3. I could also have a solid line here going up and down at 4, and x represents all the values that are bigger than 4. Well, that would just be to the right. But again, you could always find a coordinate to test. Here, they decided to test 0, 3 to prove that it doesn't work because 3 is not bigger than, oh, excuse me, we're looking at that x value. So 0 is not bigger than 4, so that would not be a solution. And they're just picking random values to double check if it is or is not a solution there. So please pause this video and complete number 1 and 2. Very good. So here, before you graph that, you did need to rewrite it into a y equals, subtract 4x on both sides, 2y is greater than negative 4x plus 8. Divide all parts by 2, so y is greater than negative 2x plus 4. So I start at 4, down 2, right 1, down 2, right 1. Here you do need to leave a generous space, so I'm not stuck guessing if your line is shaded or not. And this shows that it's all the values. Y represents all the values that are bigger than that line. Well, here that would be shaded to the right. And if you wanted to just double check, you could always test like 4, 4 here and plug it back in. So like, let's say I decided to test 4, 4 to see if in fact I did shade it correctly. Well, that would be 2 times 4, plugging it back in here, plus 4 times 4. Is that bigger than 8? It should be because I did shade that part. So is 8 plus 16 bigger than 8? Well, yes, because 24 is bigger than 8. Here we have y is less than 2. So we're going to draw a dashed line at y equals 2. Again, dashed line here. You've got to be careful on those solid or dashed lines. Make sure that I can tell the difference between your solid lines. And this represents y is less than. So smaller values of y would actually be shaded down here. And then you could always find a value of y. So for example, like negative 4. Well, is it true that negative 4 was less than 2? Well, yeah, negative 4 is less than 2. So that is correct. I shaded in the right direction.